Hello everyone, I'm Avery Fiore, and in this video I will be showing you how to draw fab sheets for Team 4817. As this is part of the summer training course, please follow along and draw fab sheets off of your own guided WCD file. For those of you who don't know, fab sheets are made for mechanical to use to fabricate all the stock pieces needed for the robot. Members are specialized in this team, so we need a way for mechanical members to quickly and accurately understand how they're meant to fabricate this robot you've CADed. Fab sheets can be drawn many different ways, some worse than others. I'm recording this video because mechanical last season liked my fab sheets the best, probably because I was once a mechanical lead. So please draw these fab sheets exactly as how I described. Alright, so we have Minura's file here for her West Coast drive, and the first step, the first official step at least, is going to be to rename all the different stock components with our identifier system. Looking at this file, we can see that not all the stock pieces are in the same components. Minura intentionally made this mistake, so I could point out that this is not ideal for mechanical. This isn't great because when they reference the CAD to build the robot, ideally they can find all the different stock pieces easily. This just makes it slightly harder, and we're trying to change this, but mechanical doesn't always have the best understanding of CAD, so yeah, just make it easier for them. Bonus points for whoever can fix their browser arrangement without screwing up the timeline. There will be times when you want to break this guideline, but generally we do want to try to put, all of the components in, all of the stock components into, one component. Okay, so that's okay. We can deal with this. We can still make the damn fab sheets. We're gonna talk about the identifier system now. Basically, there's two parts to it. The first part is going to be an abbreviation representing your subassembly. So for Drivebase, that's DB. For the rest, go look at our CAD handbook guide, or honestly, during season, it just needs to be an identifier that's different from another subassembly. So if there's intake and indexer, don't make I for both of them. Make one of them different, or both of them can be like IN and ID. Okay, so after that follows the letter that just represents a specific piece. So this will be DBA. Now, while mechanical's making this, if there's two of the same pieces, they will just want to identify one as DBA1 and the other one as DBA2. So it looks like this piece is exactly the same. What I can tell. Yep. Okay, so we just label this as DBA. Also, it will rename this to DBA bracket 1 bracket. Whatever, that's fine. Just during the fab sheet, remember to make DBA quantity 2. And we'll get to that step later. So we're going to continue naming our different components, stock components. So, okay, this is an interesting piece. Let's check if it's a duplicate or a mirror. So how do we tell the difference between a duplicate and a mirror? Oh yeah, you might want to know this trick. If you right-click, you can click isolate, and then I can just take a better look at this. What's the difference here? This is probably going to be a mirror piece, looking at it. This piece, if you just made the exact same piece, and you shifted it over to here, it would be fine. Like that's perfectly usable. There's no problems. It doesn't have to be mirrored. So that's why this is DBA1 and this is DBA2. Now, if we look at this piece here, because there are these larger holes on one side, if we just made the same piece and tried to put it on the other side of the robot, that wouldn't work, because then your cams are just not going to be supported at least the normal way that we expect. So this is actually going to be DBE, and the other piece is going to be DBM. Let's first unisolate this. Okay, so let's just check I'm right on that and make sure it is indeed a mirror. Oh, that's a bit strange. Hold on. It's just not the same piece. Okay, this is, I guess, another intentional mistake that Minera has made. While you are drawing these fab sheets, you may notice discrepancies between the different pieces, your CAD mistakes that you've made, and you will want to go fix them before you probably draw the fab sheets, and certainly before mechanical gets started. So I'm just going to time-lapse myself fixing that here. What I can tell, yeah, they're definitely supposed to be mirrors. They're just not headed that way. Okay, well, time-lapse. Okay, so now we're back. The pieces are now mirrored from what I can tell. We'll just do one final check. Isolate this. Okay. Isolate this. Cool. All right, so, yep. This is a case where this is dBp, and this piece is going to be dBm and not dB2 because of that mirror. If we again, you can't just take dBb, put it here, and that wouldn't work for this design. Okay, so this is dBm. All right, we're gonna go through the rest of the pieces. These two look similar. Okay, they're a bit different because of the holes here. So not quite the same. All right, so there are two different pieces. That's fine. So this is C. This is D. This is E, obviously. Okay, this is F. And this part shouldn't be a mirror. There's nothing on the sides. Yeah, okay, so from what I can tell, yep. This is DBF2. Or, well, they'll rename it for us. Anyways, here we go. So now we have all of the different stock components named. So we're going to get to the actual drawing part of this, right? Okay, so what we do is we right-click on the file name. We go to Create Drawing. All right, and we're going to do Contents, Select. This is a bit funky. We're going to start with this piece, DBB. Okay, you're going to want to select the template. If you're doing this for the first time, I'll assume it's not like pre-selected for you. So basically, you go to Browse, and it will just be in FRC. It's like just there. It's the only it's the only file floating in the giant folder of FRC. So you click on that. Okay, create new, yada yada. This is good, and we're going to click OK. I mean, if you care about this message, but if you can just leave it, but if you don't, check mark that. Okay, so here we have the piece in. I'm going to guess that this is a piece that wants to be a 1 to 4, given its length. You get a sense of this one the more you CAD it, and I also might be wrong. We can change that value later always. Okay, then you change your orientation to the top view, or just, well, any view, I guess, works. Something that you're gonna like draw dimensions on. This has a bunch of holes, so this is a good side to start on. You want to make sure all your other settings are the same. This is off, nothing else is clicked on, and we click down. Okay, and then we click OK. And then this is actually the wrong orientation, so we are going to rotate the piece. I click on the rotate tool. I click on this piece. I click transform. I click on this point. I click on a point below it. Now it's rotated 90 degrees. Terrific. If we need to move it, I drag it like this. I put it about there. Cool. We're going to dimension this and then include the other projected views, but I'll briefly touch on projected views here. You want to project all 4 views, all 4 sides of this piece. And then later you want an isometric view in the corner. I'll talk about that a bit later. It's a bit specific how you make that. Okay, so we're going to dimension this piece here. So the first two views, you always want to mark this length here. You can go to the snap point, that's fine. Okay, that's just, we're going to have the other piece, the other view down here, that's also going to be 1 inch, and that's just going to make it very clear this is a 1x1 stock, even though at the end we are going to label that correctly in the template down there. So, okay, next thing is the mechanical team needs to know where every single one of these holes are. Now, if the hole is on a midline between two sides of the stock, like all these holes here, we do not need to go and individually dimension that this one is 0.5 from the top edge. That is not necessary. However, we do need to give the other dimension. So let's do that. We're going to click here, we're going to click here. We're going to click there, and then we're going to click back on this dimension, and I'm going to click on this dot here, drag it on top, so it sits like that. Okay, and we're going to dimension, I'm clicking D for dimension, by the way. I don't know, I can't remember if that's a natural keybind. If it isn't, you can always re-keybind things. Click on the 3 dots. Yeah, something in there, okay? Keep going. Okay, this one's just 9. I'm gonna put it there. We want to try to make it clear enough that anyone could see these. Like maybe that's a bit close, so I'm gonna re-drag it to there. You will find that some of these snap into place, and it's just how the template works. Unfortunately, I couldn't figure out a way to fix that. So what you do afterward is you need to drag on the middle point, and that one is not going to snap as easily into place, and so I can put it there, like so. When you get to past the midpoint line, you start drawing dimensions on the other side. Now, if you think about it, okay, mechanical, if they're having a good time, they're able to fabricate accurately. This is totally fine. This can sometimes create problems when they don't cut the stock to the right length. Just something to keep in mind. Like if they, this is a 28-inch long piece of stock, and actually the full length stock length we put in dimension underneath like this. That looks a bit ugly. We're gonna put it there. Okay. If they accidentally cut this to 27 and 7/8, that's going to screw up all the dimensions, and this hole is not going to be the same. It's not going to be the correct length from that hole. Maybe that affects your piece, maybe it doesn't. But unfortunately, we found that it's just too crowded to try to mark out all the dimensions coming off of one side. So this is just what it is, but you probably should be aware of that fabrication problem that can occur. Now, if mechanical is able to fabricate pieces well, then it's not an issue. So, okay, we got this first view done. I put the stock in the right place because the dimensions are not going out of the page, so that is great. Now we are going to project the second view. If you notice in the second view, there is nothing on it, so we can just put it there, check mark that, and move on. And we're going to project this view here. This one I'm going to put a bit further down. There are no new holes, so we don't need to draw new dimensions, but we will have to label the holes. So put a bit of space. You can always drag that down a bit later. We're going to project the fourth view like that. Okay. Right. Okay. So the isometric view that goes in the corner. You need to project this isometric view from the second view, not the first one. Okay, you drag it over to the left like that, and then it does the right isometric view. And then we always resize this. So I'm going to go edit view, and I'm going to change this to, let's try the 1 to 10. Yeah, that's like it. Maybe 1 to 7. It's a bit big. Okay. Yeah, that looks good. Okay, so why do we draw it like that? If you do the isometric view from the top view, it's not going to look like this. Okay, drawing it from the second view means that the top face of the piece lines up here, and the side face that you can see lines up with this face. Okay, and that just gives mechanical a very easy to reference isometric view of the piece. Okay, so let's continue. If there were new holes appearing, these are all like, brothers of the holes above, so we don't need to mark anything there. If there were new holes appearing, we would have to mark that. We don't in this case, because it's fine. We do have to label this length here. So we're going to put that 1 inch. Move this down a bit. Okay. So Mechanical knows the positions of all the holes. Now we actually need to tell them what hole is what. Actually, okay, I forgot something here. This 28 is usually drawn on the bottom, so it's out of the way of everything. Okay, why are we doing that? You'll see in a moment. We have to actually label these holes. So we're going to make note, right? And usually the person who draws the fab sheet is also the one who CADs it. In the case that that's not the case, you can use dimension and figure out the rough radius of these things. Dimension, diameter dimension. Click on this. Why won't it let me click? Let me cook. Okay, yeah, so that would tell you what it is. I knowing that value, I know that's a 6 mm hole, right? I also just know what they're CADed. But instead of using that dimension tool, we're going to actually just add a note. This is faster and allows us to write it the way we want to. Okay, so we're going to go here. We're going to write, this is 2x because there's 2 holes of the same size in approximately the same area. And this is 6 mm. We add the diameter symbol. Okay. And these are through holes. Okay, you mark all through holes with THRU. If they're not a through hole, then you don't put the THRU. Also, if there's no mm, it's assumed that measurement is in inches. You have to put mm to signify that it's in the the metric system, sorry. And that's just the diameter symbol that you include on all hole identifiers. So we're gonna label the rest of these. 1x. Actually, I do not know this. Hold on. Okay, so this is a 1x 10 mm hole, no through, like I said. This is a 1x 6 mm through. Why did it? Okay. Just you to go there, or just you to go there. And put you in. One x 10 mm. Cool. And then we have these last two here. 2x 6 mm diameter symbol. Okay, that's readable. You have to make sure mechanical is able to read this kind of stuff. I actually think I prefer if I put this. Okay, honestly, it doesn't matter so much. Just make sure that it's like obvious if you have a 2x, like more than one, right? What holes are being referred to by that, and yeah, you'll be set. Okay, so actually we don't have to label anything down there. We can move this, we can move this, we can move this. Okay, because this is labeled as through, we don't need to relabel those holes. It's understood that those holes are going through by mechanical. Okay, so this fab sheet is like that, and then we're going to edit this template down here. Okay, so this is a 1 inch by 1 inch by 28-inch stock. Let's real quick. I did not click enter, did I? Real quick, we can isolate this, check what thickness was used. 1.5 mm. Okay. Back here. 1 inch by 1 inch, 1 inch by 1.5, and then stock. Okay, this is part DBA. This is designed by Nonura. This is drawn by me. Why do we label like that? Sometimes there will be an issue and they might want to know who designed it or who drew the fab sheet. So that is there. Subassembly, obviously this is Drivebase quantity. So we know there are 2 of these A pieces. This is revision sheet 1. Sometimes the sheets need to be withdrawn. There are no merged quantities, so this is 0. Okay, that's the first sheet. I will show you how you transition to the second sheet. Okay, so we go down here, you right click, you duplicate sheet. You will notice that this actually creates an entirely different, it creates a copy of the original one. You don't want it to be the same one or it's going to screw up your drawings, but it's just an annoying way that works. So we're going to turn off that, we're going to turn on chassis. We are going to only turn on DB. Okay, and then we're just gonna go down there, delete all these dimensions, drag back this, deselect that. Okay, hold up. Put that back there. Oh, this is a bit messy. Put you back down there. Okay, cool. So actually, we just, by duplicating it in that way, you already have the views here. You already have the scaling. You might need to change the scaling. If you change the scaling of this one, I believe all of them will change, or at least the 3 referenced off of it. This one's been messed with, so it's not gonna change like the rest of them. But as you can see, it does do that. So cool. So now we gotta label dimensions. Again, the only difference between this and that one is that this fab sheet's a bit more complicated because you have things like different diameters on the same hole. So what you would do is label the position on only one of these faces, but you would also label the diameters on both sides. So you label the diameter here on this side for the smaller hole, on this side label for the larger diameter. Mechanical understands that if they see this, that means drill the bigger hole on this specific side. They can also kind of figure that out by looking at the sheet, at the isometric view. Other things to note is that we have to draw a mirror line. So we shall do that. Yeah. Let's draw the mirror line. Mirror line is going to be over either a line across down the center of this side or this side, because this side's going to have a bunch of markings on it. We're going to put the mirror line on this face. Okay, and so what I can do is click center line, click that line, this line. Center line for me is drawn. I'm going to extend it out a bit. Okay, so that's there. I'm going to add a text box. I'm just going to put it there, and it's going to say M. And that's all we need to do for labeling that. Okay, because down here you can see that one of the instructions is mirror over M line if mirror quantity present. So later this quantity has to be changed to one normal, one mirrored. So time-lapse view, I'm going to draw this sheet, and hopefully you get the same thing as me. One thing I forgot to mention was that when labeling chamfers, you do like this. You label both dimensions. So we're actually going to put that like there. Put this like there. Another thing to mention is that if it's not a very obvious decimal, because actually mechanical like references fractions while they're making their pieces, you want to overwrite what's written here. Most people should know this is 7/8, but in case they don't, write for them like that. Okay, and if it's a 16th, that's even harder to deal with, and it should not be divisible by a 30. It should not be like a 32nd fraction in any case. You should not make a mechanical deal do that. Also, if it's not a nice number for some reason, there's some constraint that forces you to make it weird, and it's just not a fraction, give it to them in millimeters. They can then use a metric ruler. Okay, so let's say this just wasn't 11 inches, this was like 11.052, whatever, right? We would switch this to millimeters, get that value, okay, and then round it to the nearest millimeter, so that's just 279, and then you write mm. Okay, and then they'll know how to do that. But in general, yeah, you should be counting with inches, so then it just looks something like this. This is an interesting moment where this is a bit hard to... this isn't commonly CADed. So what I'm going to do here, and actually you do this for any holes that are not down the center line exactly. This is actually very common on the side of a 2x1 where like you might have like a hole half an inch from the top and half an inch from the bottom. You want to draw a line through the whole thing for all the holes that are like that, and often that means putting the line through the entire stock. In this case here, we only have we have 3 holes that are this weird measurement from the bottom edge. So we're going to label that. Now the thing is, we're going to create a drawing. Okay, and what that means is that we're not going to be able to easily reposition these views later. So I'm going to put this where I want to put it first, and then I'll go. Okay, so we're going to create the drawing now. Create sketch. Bruh. Okay, not snap to grid. That probably helps. Okay, there we go. You have to uncheck mark snap to grid. I did not see that. Sorry, team. Okay, and then we go to here. Specify that endpoint. Okay, and then you want to draw. This is a bit weird. You want to draw a line like that, and like that, just so that it can like extend beyond. Okay, that's just how I figured out what. Yeah. Okay, and then we delete this away. And then we don't want this to be continuous, we want this to be hidden too, or hidden too. Right. Okay, line width, make it thin, color is black, finish the sketch. Okay, so now that's marked off, okay, we can dimension that line by clicking this point down to here. And for some reason, whenever you do this, it will always give you a stupid value. Hold up. Okay, well this time it did its job. Sometimes it'll give you the wrong value and you have to just retype it. Okay, so this is 1 dash, yeah, that's a 16th. Okay. Yep, I'm right. Okay, so that's a 16th. So you do that in that case. Often these dotted lines would go through the entire thing. When you have multiple holes, almost spread out through the entire stock on that line. Okay, and that means you might have to do that line trick I showed you. You draw a line here, you draw a line, and then if this piece is stock, you extend, you delete the additional lines you drew, and then you can, like, dimension it properly like this. Okay, this case, it's a special case, and it's like that. That's what I think makes sense there. That's strange. So I know this is for the cam, which is a 1032 hole. Okay, well anyways, this is in quick reference, so we'll just label it as a 1364. So just to be clear here, drill bits have all sorts of different sizes. Like the drill hole size can be a 60 divisible by a 64th, but like hole position should be at most divisible by a 16th. Or like over 60, if you know what I mean. Like, it shouldn't be a 32 fraction. Okay, that was a behemoth of a fab sheet. Well, sometimes they look like that, and yeah, but as far as I can tell, I think mechanical would still find this readable. Just a bit cramped, but they can do this. They would understand this. This was probably the hardest piece to draw a fab sheet for. The rest of them should be relatively straightforward. Okay, one thing I didn't make clear, you want the thin view on top. And preferably the fillets the other way, so. Okay, so this is the first view. Another thing, you always draw the dimension to the lower hole, in this case here, so like, that line just goes through both, so it's very clear both are 0.5. And the fab sheets are almost done. One thing we have to go back and do now that, well, I mean, I guess I should have known that would be 6, but we gotta go get the page numbers. Okay, and I believe we are done. Mechanical tends to notice mistakes and will complain to you if anything is not drawn properly. Oh my gosh. Okay. I didn't even do any. Okay, well, that's stupid. Hold up. I didn't even do any holes in this. Okay. Well, that's what we check. Okay, and now the fab sheets are actually done. Alright, so now you can look at my fab sheets and compare how well you did. Probably should have saved earlier, but, well, okay, I haven't yet, so we're going to save the file. So you would just name it the normal file name and then put fab sheet. I'm going to put in the do not use training folder. Obviously, you guys just put it in guided WCD. Cool. And then for reference, you go to this export button to get the PDF that you would probably send off to mechanical. That's all for fab sheets. As usual, you can refer to a summary of the information in the slideshow.